So let's start from the beginning, please. Introduction. This course will take us into yet another P block elements from group 4 to group 7. Starting from unit 1, the elements of group 4. Let's go to slide 2. The objectives of this unit. After studying this unit, the students should be able to explain the occurrence, extraction, and uses of the elements of carbon family, explain allotropy and their various forms of existence and catenations in carbon, describe bonding and complex formations by elements of this group, describe the halides, hydrides, and oxides of this group, describe the silicates and silicons, their structures, uses, and the divalent compounds of these elements. Let's start with occurrence. Carbon is an essential element in all living things. It occurs naturally. Carbon, even though all living things contain carbon, carbon occurs naturally in two allotropes, diamond and graphite. Coal and petroleum, known as fossil fuels, also contain carbon. They are the amorphous forms of carbon. Silicon is the second in abundance in the Earth's crust, forming about 27.7%. Germanium is a rare element and occurs in traces in coal. Tin occurs mainly as cassiterite or tin stone. Lead occurs as galena. These are the elements in group 4: carbon, silicon, germanium, tin, lead. So we have seen their occurrence. Let us look at allotropy. As I said, the carbon has two main allotropes, the graphite and the diamond. Then we have the amorphous forms of carbon. We look at allotropy. What is this allotropy? Allotropy is the existence of an element in more than one form. When an element exists in more than one form, it can exist in this form, it can also exist in another form. We take carbon as an example. Carbon has two allotropes. That is, carbon can exist as diamond. It can also exist as graphite. Each carbon atom in diamond are tetrahedrally bonded to 4 other carbons. Diamond is an essential insulator and hardest substance known. Because they are tetrahedrally bonded, they are closely bonded. Graphite is soft because it is held by weak force, that is the van der Waals forces only. Graphite is a good conductor of electricity. Remember I said it is held by van der Waals forces. Carbon also exists in all amorphous forms like lamp black. Silicon and germanium exist only in one form, that is diamond. Remember, carbon exists in two forms. The diamond and graphite. There are also all amorphous forms of carbon. It shows polymorphism and exists in two crystalline forms, the gray and the white tin. Lead exists in one crystalline form with a distorted cubic closed packed structure. How are these things extracted? That's extraction. Diamond and graphite occur in nature, though their artificial forms can be manufactured. A new form of carbon known as fullerene also exists. We treat it further when we move up. These atoms are arranged in closed shells, that is the fullerene. Other forms of carbon include charcoal, carbon black, or lamp black. These are amorphous forms of carbon. Coke and coal are formed by the destructive distillation or pyrolysis of coal and hardwood or bones. Carbon black are formed by burning petroleum gas and natural gas, limited supply of air. Physical properties. They show oxidation states of +2 to +4, except carbon, which varies, that is other groups of elements show oxidation states of +2 up to +4, except carbon, which varies from -2 to +4. So while silicon, germanium, lead, and tin shows the oxidation state from +2 to +4, carbon shows from -2 to +4. The stability of the +4 oxidation state decreases down the group, while the stability of +2 oxidation state increases down the group. What does that mean? It means that plate 2 is more stable than tin 2. Tin 2 is more stable than germanium 2. Germanium 2 is more stable than carbon 2. So the physical properties of these group 4 elements are summarized in the table below. See the table. Catenation is the ability of elements to form long chain compounds by single or multiple bond formation between atoms of the same element. It occurs highly in carbon due to its small size and high bond energy. Examples of catenation in carbon are seen in alkanes. Example: ethane, propane, butane, pentane, hexane, heptane, octane, where carbon has links with other carbons to form these various bonds. Then in alkenes, ethene, propene, butene, and so on. Even with alkynes, you can also see catenation in polyvinyl chloride. Polyvinyl chloride. Chemical properties. The chemical properties in group 4 elements increases down the group. They form carbides, halides, fluorocarbons, hydrides, and oxides. Carbides are formed when carbon combines with elements of lower or equal electronegativity. Carbides are classified into the following: A. Salt-like or ionic carbides. B. Interstitial carbides. 3. Covalent carbides. Interstitial carbides are formed by combination of carbon with some transition metals like deuterium, vanadium. When carbon combines with elements of group 1, group 2, group 3, group 11, group 12, group 13. So it happens when carbon combines with say that of boron. Carbides are decomposed by water and dilute acids. That is, ionic carbides are decomposed by water and dilute acids. Then covalent carbides, when are they formed? Covalent carbides are formed by combination of carbon with elements of almost equal electronegativity. When carbon combines with elements of equal electronegativity, you have covalent carbides. Remember I said salt-like carbides occur when carbon combines with elements of group 1, group 2, group 3, 11, 12, 13, but except boron. I can give you an example: calcium hydride, carbon hydride. Then interstitial carbides, when carbon occurs with transition elements, while covalent carbides occur when carbon combines with elements of almost equal electronegativity. Complex formation. Carbon can have a maximum coordination number of 4. So carbon has a maximum coordination number of 4 and therefore do not form complexes. It has a coordination number of 4 and do not form complexes. Others can form complexes by expanding the coordination number to 6 or 8 in the case of heavier elements like silicon. They form complexes, while carbon does not form because it has coordination number of 4. So we look at anomalous behavior of carbon. These behaviors in carbon that are not seen in other elements of group 4. The elements in group 4 as carbon, silicon, germanium, tin, lead. All these elements in group 4, they present similar properties. But carbon, the first element, has some behaviors that are anomalous to the other members of the group. Such behaviors we will look at now. 1. Carbon cannot form complex because it has a maximum covalency of 4, while others form complexes. It forms stable derivatives with double and triple bonds. Carbon forms gaseous oxides, example carbon 2 oxide, carbon 4 oxide, while others form solid oxides. Carbon has higher electronegativity and ionization energy than others. It has a unique capacity for catenation. We looked at catenation before. Carbon forms stronger bonds both with itself and with other elements. Example, halogens, oxygens, nitrogens, etc.